Hey guys, today's lesson is going to be on adding and subtracting rational expressions. So we're just picking up where we left off last time. We simplified, multiplied, and divided rationals. Today we're going to add and subtract rational expressions. Remember, a rational expression is an expression that has a variable located in the denominator. So here's our first question. We're going to simplify by adding these two rational expressions together. If you'll remember what you know about fractions, in order to add or subtract fractions, we must first have a common denominator. So our first goal here is to get a common denominator for the two fractions shown. So I'm going to look at both the numbers and the variables when identifying a common denominator. So first, if I look at the number 3 and the number 18, what is the least common multiple that 3 and 18 that can both go into? And the answer to that is an actual 18. So the fraction on the right already has an 18 in the denominator. We need to multiply the fraction on the left by 6 to give that a denominator of 18. Remember, whatever you do to the bottom, you also do to the top. So in both of these fractions, we now have a denominator of 18. So what we're really doing is we're building our least common multiple. Our least common multiple is the smallest multiple that will give me a common denominator. So 3 and 18 both go into 18 evenly. Now let's take a look at the variables. If you notice, on the left I have an a squared, on the right I have an a. So the smallest multiple would also be an a squared. So to make the denominators the same, I need to multiply the fraction on the right, both top and bottom, by an a. So on the left, I now have 18a squared. Here's my 18a squared on the right. The right fraction has an x, so we need to put an x on the left fraction. Whatever we do to the top, we do to the bottom. And the left fraction has a b in the denominator, so we need to also make sure the right fraction has a b in the denominator. So our common denominator is actually going to be 18a squared bx. So let's take a moment to clean up these fractions. On the left, I have 12x over 18a squared bx, plus on the right, I have 7ab over 18a squared bx. Now we have a common denominator. Once we have a common denominator, we can add or subtract our fractions. So when we're adding or subtracting fractions with a common denominator, we keep the denominator and we add or subtract the numerator. So this is 12x plus 7ab. I end up with 12x plus 7ab all over 18a squared bx. Now, if I can simplify, I'm going to want to simplify and reduce in any way I can. I can't simplify anything in the numerator because in order to simplify, I would need to be factored, and there is no greatest common factor in the numerator. I cannot cancel a binomial unless I look at factors that I can factor out. So this is my final answer. Let's try another one. Let's simplify by adding 1 over 12a plus 6 minus 3 over 5a squared. This one's a little different. I actually have a whole number now, but you know that we can write any whole number as a fraction. So I could really rewrite this as 1 over 12a plus 6 over 1, which is the same as 6, minus 3 over 5a squared. Now let's work on getting a common denominator for all three fractions. So I can start with the whole numbers. What is the smallest multiple of both 12 and 5? In other words, what's the smallest number that they both divide into evenly, or that is a multiple of both 12 and 5? The answer is 60. So each of these denominators will need to be 60 and something else. So I need to multiply this denominator by 12, this by 60, and this by 5 to give all of them a denominator of 60. Now I'm looking for the least common multiple of a squared and a, and that would be a squared. So my common denominator would be 60a squared. Well, he's already set up. He's got an a squared. This guy needs an a squared. And this guy's already got an a, so we just have to multiply him by a to give me a denominator of a squared. So it's kind of hard to see what we've done here. If we take the first fraction, it's 5 times 1 times a, or 5a, over 60a squared, plus in the second I've got 360a squared over 60a squared minus 36 over 60a squared. Now that we've got a common denominator, we add or subtract the tops and keep the bottom. So I'm going to keep my common denominator along the bottom, and on the top I have 5a plus 360a squared minus 36. And again, I cannot cancel in the trinomial in the numerator any of those terms. I could only cancel this if it happened to be factored. Now, if I go ahead and factor this, it still wouldn't reduce because I would end up with the binomial times the binomial, and then the denominator, I have a monomial. So there's nothing that I can do to clean this up or simplify. There is no greatest common factor in the numerator. So while it's kind of an ugly answer, it is my final answer. Now let's change gears a little. Let's take a look at what happens when we have a fraction with binomials in the denominator. So I'm trying to make sure that this fraction and this fraction have a common denominator. And remember, I'm looking for a multiple. I can multiply the denominator by anything to get a common denominator. I can't add or subtract to get a common denominator. Let me kind of show you what I mean. If you'll recall from early years in fractions, let's say I have 1/2 and I would like to change the denominator. Let's say I want to get a common denominator between 1/2 and 3/4. I can multiply the bottom and the top by the same thing. In doing that, I get 2/4, which is the same as 1/2. I actually haven't changed the fraction. If, though, you tried to add 2 to the bottom and the top, I would have gotten 3/4, which is clearly not the same as my original fraction of 1/2. I'm not going to keep fractions equivalent if I add or subtract a value to the numerator and denominator. I only keep them equivalent if I multiply the numerator and denominator by the same thing. So in getting a common denominator, we need to make sure we're keeping the fractions equivalent. We're not changing any values in the problem, we're just rewriting it. So the tip here is let's go ahead and factor the denominators on both of these fractions. So my greatest common factor would be a 3 here. I would factor that out. Minus, I've got 3x plus 15, and the denominator, my greatest common factor, is a 6. So now if I look at these two terms, I want a common denominator. Well, they both already have an x minus 5. So my least common multiple will definitely have an x minus 5. And then the smallest multiple of both 3 and 6 is 6. So my common denominator is 6 times x minus 5. So the fraction on the right already has the correct denominator. We need to multiply the fraction on the left by 2 to get the correct denominator. Remember, whatever I do to the bottom, I do to the top. Now be careful here. I don't write it like that. I need to remind myself that I'm multiplying the entire numerator of this fraction by 2. So if we clean up what we've got here, this is 2x plus 20 over 6 times x minus 5 minus 3x plus 15 over 6 times x minus 5. Now I'm subtracting fractions. Since they have the same denominator, I keep the denominator and I subtract the tops. 2x plus 20, now be really careful here, this minus has to distribute to everything behind it. So I'm subtracting this entire binomial. So I'm subtracting 3x and I'm subtracting 15. So now I need to combine my like terms so I can simplify. 2x minus 3x is negative x. 20 minus 15 is a positive 5, all over 6 times x minus 5. If you notice, I've got x's and 5's. They're almost the same and they could reduce. It's just the sign that's off. So let's go ahead and factor out a negative 1 as my greatest common factor in the numerator. If I factor out a negative 1, it means I'm dividing each of these terms by negative 1. Now be careful, I have not changed the fraction here. If I read this fraction, it's still negative x plus 5 in the numerator. I've just written it in factored form. In doing so, though, I have a problem that can now be reduced. Anything divided by itself is 1, and I'm simply left with negative 1/6. All right, let's take a look at this problem. If you look at the denominators, we're trying to find a least common multiple of both of these denominators. And again, my real rule of thumb should be if factorable, I need to factor first. If we look at the denominator on the left, hopefully you recognize that 16x squared minus 81 is a difference of two squares. So before we go any further, let's factor. On the left, I have negative 4x plus 9, and I'm going to factor the denominator. Nothing on the right is going to change. In factoring a difference of two squares, I take the square root of the first term, I take the square root of the last term, and the factors are conjugates. One's a positive, one's a negative, and that way when I multiply them all out, when I double distribute, the middle term is canceled, and I actually get 16x squared minus 81. So now if we look at the denominators here, this fraction has a 4x plus 9, and so does this fraction. To give the same denominator, I simply need to multiply the fraction on the right by 4x minus 9 so that it has the right denominator. As long as I do the same thing to the top and the bottom, I haven't changed the fraction at all. So if I multiply the bottom by 4x minus 9 and the top by 4x minus 9, all I've done is really multiply by 1. Now the denominators are the same. So I have negative 4x plus 9. Remember, I'm going to add or subtract the tops and keep the common denominator. And then this is minus 2 times 4x minus 9. Remember, I need to take this negative 2 and distribute it to everything in that parenthesis. So the numerator becomes negative 4x plus 9 minus 8x plus 18 all over 4x plus 9 times 4x minus 9. Let's clean this up, combine our like terms, and simplify the numerator. I have negative 12x plus 27 over 4x plus 9 times 4x minus 9. The only way for us to reduce is if we factor the numerator. If I pull out the greatest common factor of negative 3, I'm left with 4x minus 9. In the denominator, I have a 4x plus 9 and a 4x minus 9. Now that I factored the top, I can reduce this to become negative 3 over 4x plus 9. And that's my final answer. We've done some with binomials in the denominator. Now let's look at trinomials. Remember, we need to factor the denominators. So I have 2 over, the greatest common factor here in the denominator is 2. I'm going to factor that out. I'm left with x squared plus 3x plus 2. On the right, I have 3x over, factoring out my greatest common factor of 3, I have x squared plus 3x plus 2. We need a common denominator. Both of these fractions have a denominator of x squared plus 3x plus 2. I now just need the least common multiple of 2 and 3, which is 6. So I will multiply this fraction by 2 and this fraction by 3 to get my common denominator. So I end up with 6 over 6 times x squared plus 3x plus 2 plus 6x over 6 times x squared plus 3x plus 2. Well, really, I guess I could have noticed over here that when I started, I had a way to reduce this before I even began. So we can actually reduce this now. Let's go ahead and reduce both the top and bottom of each fraction to simplify. So on the left, I divide the top by 6 and the bottom by 6. So I have 1 over x squared plus 3x plus 2. On the right, if I divide the top by 6 and the bottom by 6, I have x over x squared plus 3x plus 2. We add or subtract the tops, x plus 1, and keep the denominator. Now, make sure we always factor completely so that we can see if anything needs to be reduced. If I'm looking at this fraction right here, I cannot reduce the way it's written. But if I will factor the denominator, in order to get my first term of an x squared, I would need an x and an x. I'm looking for positive factors because they multiply to a positive and add up to a positive. I'm looking for two numbers that multiply to 2 and add up to 3. And now if I reduce, I'm simply left with 1 over x plus 2. All right, let's try 2 more and see how you do. Let's take a look at this one. In order to add or subtract now 3 fractions, again, we need a common denominator. So let's start by factoring. The numerator here is not factorable. Be careful. He's a sum of 2 squares, and there is no way to factor that. I can, however, factor the denominator. The denominator is a difference of 2 squares. So we take the square root of the first term, the square root of the last term, and their conjugates. One is a plus, one is a minus, so that the middle term cancels. Plus y over x plus y minus x over x minus y. Again, let's look for our common denominator. X plus y, x plus y. This fraction needs a denominator of x plus y as a multiple. Whatever I do to the bottom, I must do to the top to keep the fraction balanced. He's got an x minus y. This one has x minus y. I need to multiply both the top and the bottom of this fraction by x minus y. So now I have x squared plus y squared plus y times x minus y minus x times x plus y in the numerator, all over x plus y times x minus y. Please be careful. You cannot reduce or cancel. The numerator has multiple terms separated by addition or subtraction. In a polynomial expression, you cannot reduce. You can only reduce if we combine our like terms and are able to factor. So let's clean up the top. X squared plus y squared plus xy minus y squared minus x squared minus xy all over x plus y times x minus y. If we combine our like terms, we notice that x squared minus x squared will cancel. Y squared minus y squared is 0. Xy minus xy is 0. So when I look at the numerator, I'm left with 0 over x plus y times x minus y. 0 divided by anything is simply 0. All right, now for our final problem. I really have a complex fraction here. In the numerator of this fraction, I have a fraction plus a fraction. In the denominator, I have a fraction minus 1. When you have a complex fraction, here's some good rules of thumb. Clean up the numerator first and the denominator, and then take care of the big fraction. I'm not able to multiply by the reciprocal right now because it would be very difficult for me to figure out what the reciprocal is of 1 divided by b minus 1. So let's start by cleaning up the numerator and the denominator. In order to clean up the top and bottom so that my goal here is to have just one fraction in the numerator and one in the denominator, I need a common denominator. So on top here, my common denominator of a and b is going to be ab. So I have an a, I need to multiply by a b. Here I have a b, I need to multiply by an a. In the denominator down here, I need a common denominator of b. So if I clean up what I have on top, I have a plus b over ab divided by 1 minus b over b. Now I have one fraction in the top, one fraction in the bottom. We can divide. Remember, in order to divide fractions, you keep the top and you multiply by the reciprocal of the bottom. Top times top, bottom times bottom. I'm left with b times a plus b over ab times 1 minus b. b divided by b is 1. I have a plus b over a times 1 minus b, and that's my final answer. Or if you really want to, we could distribute the denominator and have a minus ab. Today we worked on adding and subtracting rational expressions. If you have any questions, let me know.